Hello friends, welcome to our channel Franklin's Touch. In the last video, we have seen the various types of AC motors in the part 1. Today, we will see the various classifications as well as the types of wound rotor motors in the AC motors part 2. Let's get started. The classification of AC motors are generally of two types, asynchronous and synchronous motors. Further, these induction motors are classified under two heads, squirrel cage and wound rotor. Under the wound rotor, we have three-phase and single-phase wound rotor motors. The single-phase has further division into repulsion and repulsion induction motors. Three-phase wound rotor induction motor. It is the induction motor whose three-phase rotor winding in a star configuration and is connected to the slip rings. The slip rings connect to the external terminals through carbon brushes, which is why these motors are also called as slip ring motor. Let's see the construction and working principle of the three-phase wound rotor induction motor. A wound rotor induction motor has a stator like a squirrel cage induction motor, but a rotor with insulated windings brought out via slip rings and brushes. However, no power is applied to the slip rings. Their sole purpose is to allow the resistance to be placed in series with the rotor windings while starting. This resistance is shot out once the motor is started to make the rotor look electrically like the squirrel cage counterpart. The symbol of the three-phase wound rotor induction motor is shown in the figure. The various applications are conveyors, compressors, cranes and hoists, crushers, plunger pumps, etc. The various advantages and disadvantages of the three-phase wound rotor induction motor are the excellent starting torque for high inertia loads, low starting current compared to a squirrel cage induction motor, speed is resistance variable over 50% to 100% of the full speed are the various advantages, and complication and maintenance associated with brushes and slip rings, high inrush currents, very worst power factor about 0.3 to 0.5 lagging are the various disadvantages. Single-phase repulsion start wound rotor induction motor. It is an AC motor which starts as a repulsion motor and runs as an induction motor. The starting torque should be high for the repulsion motor and very good running characteristics for induction motor. Now, let's see the construction and the working principle. The stator carries a single-phase exciting winding similar to a split-phase motor. The rotor has a closed-type armature winding with a commutator and the brushes similar to the DC series motor. When the stator winding is energized from a single-phase supply, EMF is induced in the rotor conductors. By Lenz's law, the direction of the EMF is such that the magnetic effect of the resulting armature currents will oppose the increase in the flux. The symbol of the single-phase repulsion start wound rotor induction motor is shown in the figure. The various applications include mining devices, hoists, refrigerators, pumps, fans, and compressors. The various advantages and disadvantages of the single-phase repulsion start wound rotor induction motor are high starting torque, low starting current, better power factor than a single-phase induction motor includes its advantages. The various disadvantages are more maintenance, it's more expensive, the starting noise is more, causes radio interference when starting, its direction cannot be reversed easily. Single-phase repulsion induction wound rotor induction motor. In the repulsion induction motor, the high starting torque is due to repulsion motor action. While in operation, the repulsion induction motor functions through a combination of repulsion motor and the induction motor action. Let's see its construction. It consists of a stator which carries a single distributed winding fed from the single-phase AC supply. The rotor of the repulsion induction motor has two independent windings placed one over the other. The inner winding is a squirrel gauge winding with the rotor bars permanently short-circuited. The outer winding is a repulsion commutator armature winding which is placed over the squirrel gauge winding. The repulsion winding is connected to a commutator on which ride short-circuited carbon brushes. It works on the principle that when a single-phase AC supply is fed to the stator winding of the repulsion induction motor, the repulsion winding is activated since at starting the impedance of the repulsion winding is less than that of the squirrel gauge winding. As a result, the motor is started as a repulsion motor with a corresponding high starting torque. As the speed of the motor increases, the current shifts from repulsion winding to the squirrel gauge winding due to the decreasing impedance of the squirrel gauge winding with increasing speed. Therefore, under the running condition, the squirrel gauge windings carries the greater part of the rotor current. Consequently, the repulsion motor action is shifted to the induction motor action and it is achieved without any switching arrangements. The various applications of the single-phase repulsion induction wound rotor induction motor are refrigerators, air conditioners, mining devices, high-speed lifts, pumps, hoists, air compressors, fans, etc. The various advantages and disadvantages are high starting torque, low starting current, wide range of speed control includes their advantages. The main disadvantage is its maintenance is more. If you like this video, please share and subscribe. Thank you.